We've learned about um, chemical reactions, how to write them and how to balance them. We've learned about solubility rules. That was the introduction for our first series of different type of reaction, and the first one is precipitation reaction. So we are going to learn how to write the product of the precipitation reaction, and we already know how to balance them, right? So precipitate, what is precipitate? It's a solid formed from a solution, and I don't know why I write form and in a solution. So it's you can omit that. So a solid formed from solution. When you add two things together and you form a solid, that's a precipitate. How do you predict the precipitate? So we've learned about solubility of the compounds, right? So when an ionic compound is insoluble in aqueous solution and it is formed after mixing two ionic compounds, that would be your precipitate. So the cation anion combination, which forms an insoluble solid, is the precipitate. Okay, then you can write the reaction equation, and then you can balance it. So you can see that when we are, the top solution here is potassium iodide, Ki, and it's in solution, it's aqueous, and it's soluble. So when you're adding the Ki to the solution, then we have here as lead nitrate, PbNO3. When we add that, this yellow solid is being formed. Okay, so what is that yellow solid? So as you can see in this molecular view of the solution, so we talked about hydrated ions, right? So when you dissolve Ki in solution, we have potassium ions and iodine ions, like separated from dissociated into the ions. Okay, they are separated. Also, in lead nitrate, you had lead ions and nitrate ions. Okay, they are separated. But as soon as you mix these two together, the mixture of lead and iodine, if you check the solubility rules, halide with 3 ions make solids. They're not soluble, they're insoluble, and Pb was one of them. So they form a solid which is not soluble, and the color is yellow. So it forms this solid as the precipitate. How can we predict the precipitation reaction and writing the equation? Well, the first step is to write the reactant. If you've been said that, for example, I don't know, copper sulfate reacted with something, I'm just bringing things from my mind. So when you hear the name, you have to know how to write the formulas. When you know the right formula for the reactants, you can predict the product. How do we do that? Each compound is an ion pair, right? It has a cation and anion. So when you have two reactants, we have two pairs of anion and cation, right? So the product is going to be a partner swap. Okay, so they change the ions together, they swap the ions together, they change the partner. So you do that, and then the third step is to go through the solubility rules. You can check it from the slides that we had in the previous video, or you can check the table 4.5 in your textbook, and then see if the products that you made, if they are soluble or insoluble. If they are soluble, then it means there is no reaction. Because if they're soluble, what happens? When you have a soluble compound in a solution, you have just free ions, therefore nothing happens, right? So there is no reaction. If it is insoluble, it means one of these two pairs is crushing out of the solution, so you don't have it anymore, so you make more and more and more of it. The more you add the reactant, the more product, which is an insoluble precipitate, you make. Okay, so if it's insoluble, the insoluble product would be your precipitate, and that's a precipitation reaction that is occurring. If no, there is no reaction that's happening. And the last step is to balance the reaction, just like any chemical reaction. So let's practice what we were talking about. So write a balanced reaction when a solution of potassium phosphate and iron 3 acetate are mixed. Okay, so these are our two reactants. So you should be able to write the formula when you have the name. It's potassium phosphate. Phosphate is a polyatomic ion that you have to memorize. That's a charge. And potassium, it's in group 1 plus 1. Okay, so you crisscross the charges. So the ion is K3PO4. Okay, plus, and what is the phase? You have to write the phase too. So phosphate are all insoluble except when you have metals from group 1, which potassium is one of the group 1 metals, so it is soluble. So if it's soluble, you write AQ. Okay, the other reactant is iron 3 acetate. So iron 3, what is that 3? What does that 3 mean? So it means 3 plus, that's the charge of the iron. So 3 and acetate, well, you can write it like this, or I think in your textbook they write it like C2H3O2. Both of them are right. Okay, so let's be consistent and write it just like your textbook writes. So let me erase this and erase this one. So it's C2H3O2 minus, and that's one of the polyatomic ions that you have to memorize. Okay, so this has 3, this one is 1, so when they change the well, you know, it's better to put this on here and write the chemical formula without the charge in the bottom, because when you write the formula you should not write the charges, right? So just want to show you that the charge, how you write the formula, and then when you write it you don't write the charges, right? So it's C2H3O2 and you have 3 of that. Is it soluble or not? Well, you know, all the acetates, they're all soluble, no exception. So this is AQ. Okay, so this is your reactant. How do we write the product? So we say we swap the partners, right? So what are the partners? You have potassium and phosphate, you have iron and acetate. So you write the cation of the first one. Let me change the color. You write the cation of the first pair with the anion of the second pair, and the cation of the second pair with the anion of the first pair. So they change the partners. Okay, so we have potassium with acetate. So potassium plus acetate, C2H3O2 minus. Then we have to write, you have to see if it's charge balanced. It's 1 and 1, so it's balanced, so we don't need to write anything else. So that's the chemical formula. And let me erase the charges, so we don't need to write the charge. Okay, so what is the the phase? Is it soluble or not? Well, still it's acetate, and all acetate are soluble, no exceptions, AQ. The next one, I write it here. So the cation from the second one with the anion of the first one, so it's Fe3 plus and PO4 3 minus. Well, it's charge balanced, you have to charge balance it. It's 3 plus and 3 minus, so it's balanced, we don't need to add anything else. So let me erase the charge, and I can put the phosphate closer to iron, so it's FePO4. So is it soluble or insoluble? Phosphate are all insoluble except acetate, ammonium and acetate is a negative, ammonium and group 1 metals, okay, which iron is not group 1 metal, therefore this is insoluble. When it's insoluble, that's our precipitate, so the phase is S, it's solid, okay. So that's how we write the precipitation reaction chemical equation, okay. So you have to check if it's soluble, you write AQ, if it's not soluble, it's S, okay. So that's the chemical equation. Last step, we have to balance it. So as we said, when you have polyatomic ions, it's better to balance the whole ion pair together. So we have potassium, we have phosphate, we have iron, and we have acetate, C2H3O2, okay. So how many of each of these do we have in the reactant and product? So for potassium, we have 3 in the reactant, we have 1 phosphate, we have 1 iron, and we have 3 acetate. In product, we have 1 potassium, 1 acetate, 1 iron, and 1 phosphate. So the first one for potassium, we have 3, we have 1, we need 1 more, and we need 3 in the product, so we add 3 here, so now we have 3, and we also have 3 acetate, so we have 3 acetate. The rest of them, it seems like it's balanced, right? So 1 and 1, 1 and 1, 3 and 3, so it's balanced. We just need these 3 here. So that is the balanced chemical equation for a solution of potassium phosphate and iron 3 acetate. Okay, here is another example. So I want you to pause and try to do this yourself to practice, and then check it with me. So the first step is to write the correct chemical formula for the reactants, sodium sulfate and lead nitrate, okay. So sodium is Na plus, phosphate is a polyatomic ion, SO4 2 minus. So you crisscross the charge, so it's Na2SO4. Is it soluble? Well, sulfate are all soluble except CBS, happy, so calcium, barium, and strontium, happy, Hg, Ag, and Pb. Okay, so this is not from on the exception, so therefore it's aqueous. Plus lead nitrate, so it's Pb, and it's 2, so it's 2 plus. And nitrate is a polyatomic ion that you have to memorize with the charge, with 1 minus. So you crisscross the charge, so it's Pb, NO3, 2. Okay, is it soluble? Yes, all nitrates are soluble, so it's AQ. So to write the product, how do we write the product? We swap the partners, right? So we have sulfate and sodium. Here we have lead and nitrate. So the cation of the first one goes with the anion of the second one, and the cation of the second one goes with the anion of the first one, okay. So sodium with nitrate, sodium is plus, nitrate is minus, so it's charge balance, therefore we don't need to change anything. So that's the right formula, and I have to erase the charge. So first you write the charge to make sure if it's balanced, if it's charge balanced, or if you need to add more sodium or nitrate to make it charge balanced. When you figure out the formula, then you have to erase the charges. So the next one is the cation of the second one with the anion of the first one. So it's Pb, 2 plus, and sulfate is 2 minus. Again, it's charge balanced, so we don't need to do anything. We just erase the charges, and that's it. Oops, we forget about the phases. So the first one, sodium nitrate, is it soluble or insoluble? All nitrates are soluble, so therefore this is AQ. Sulfates are soluble except with those 6 ions, and Pb was one of them, therefore this is not soluble, so it's S, it's solid. So it's our chemical equation. Now we have to balance it, so we balance with the ions instead of each element. So we have sulfate, we have Pb, and we have nitrates. Okay. So in the reactant we have 2. Look, we have these 2. So we have 2 sodium, we have 1 sulfate, we have 1 Pb, and we have 1 nitrate. 2 nitrates. Sorry, 2 nitrates. In product, we have 1 from each. Right? Sometimes students mix up these 4 and say we have 4 sulfate. We don't. This 4 is part of the polyatomic ion. Okay, sulfate itself is SO4. It doesn't mean we have 4 of that. We have 1 SO4, so it's 1 sulfate. Okay, so to balance it, the first one, sodium, we have 2 in the reactant, 1 in the product, so we need 2 of that, so I write 2 here. So we have 2 sodium, we also have 2 nitrates, so this is 2. Sulfate is 1 and 1, lead is 1 and 1, and nitrate is 2 and 2, so it's balanced. So this is the balanced chemical equation for the precipitation reaction of sodium sulfate and lead nitrates.